guys, it's the last day of new notes in the Trig unit. It's day 14. Great thing is it's one page, short and sweet. That's it. All right. What we are looking at today is the tangent graph. So we have done a bunch with graphing sine and cosine and shifting it and doing all sorts of stuff. We are not going to shift the tangent graph at all. We just want to look at what does it look like. All right. So what I actually want to use to be able to kind of break down and have nice points to plot is I want to use the unit circle. So we use the unit circle where the radius is equal to 1 to evaluate all the quadrantal angles. We're used to that. All right. So if I draw myself a little circle over here, the quadrantals happening at 0, where it's 1, 0, pi over 2, where it's 0, 1. Over here we got pi, that's the point, negative 1, 0. And then we come all the way down to 3 pi over 2, that's the point, 0, negative 1. And then, of course, you come right back to 2 pi and you can keep on going. All right, as a reminder, we know that cosine is equivalent to the x-coordinate, sine is equivalent to the y-coordinate. What you might not remember as well, but you know it, is that tangent is equal to sine over cosine, or in this case, y over x, because that's the TOA part if you put that together. All right. So what I want to do before we graph this is I want to create just a little chart. So we're going to make a list of the angles. And then with it, we're going to put what is the tangent of those particular angles. So keep in mind, theta is the angle itself, oops, right off the screen there. And then tangent of the angle is what we're looking at. Mm-hmm. So the quadrantal angles are what I want to use. So let's put 0, and then pi over 2 radians, pi radians, 3 pi over 2, and then let's go right back to 2 pi. Okay, for each point, remember, we're doing the y-coordinate divided by the x-coordinate. So I'll do the work beneath it. So the y-coordinate here, so here's x, there's y, would be 0 over 1 or 0. Up top, y divided by x would be 1 over 0. You know that. That's undefined, right? Or you can abbreviate it however you like. Come on over to pi, y over x, 0 divided by negative 1, still 0. Come to 3 pi over 2, y over x. There's another case where 0's in the denominator, and we're looking at undefined. Right? And then back to 2 pi, well, it's going to be the exact same as what we had at 0. It would be 0 over 1. And so it's going to keep repeating. So when you look at this, you keep getting values of 0, undefined, 0, undefined. There's obviously more going on than just those two values because those are just the quadrantal angles. But what I want to remind you of is this will actually give us a little bit of a basis for our graph because 0, 0, that's an easy point to plot. And then anywhere that the graph is undefined, that's the same thing as having a vertical asymptote. So that's that vertical line that we always draw and dot it. So that's what I want to do right now. So give yourself just a little set of axes to work with. And I want you to extend it out the x-axis a little ways, or theta. And then our y here, that's our ratio. So this is x, that's y. Remind yourself of that. All right, so I want to label on the x-axis all those quadrantal angles. So we've got 0 right here, and then we can go pi over 2, pi, 3 pi over 2, 2 pi, and it would keep going. So I actually want you to label one further. Let's bring it out to 5 pi over 2. That would be the next quadrantal angle. All right, plot all the zeros. So it's going to hit 0 at 0 itself, at pi, at 2 pi, and then it would be 3 pi, 4 pi, and so on. Right? I also want to extend the graph back a little ways. Let's back it up to negative pi over 2. Right? The reason for it is what you're going to notice is if I have 1 pi over 2, 3 pi over 2, the next one would actually be over here at 5 pi over 2. Those are all going to be undefined. So it's any odd coefficient there on it. So at pi over 2, we're going to put in a vertical asymptote, 3 pi over 2, 5 pi over 2, and the same thing would go back here for negative pi over 2. All right, what the heck happens in between here? Well, you'd have to plot more exact values, but as long as you trust me, from 0, it's going to kind of curve on over and up and run alongside the asymptote. And then it's going to start at the bottom and repeat that. So it starts way down here, kind of comes on up, hits 0, passes through it, so that it always runs along the edge of the asymptote. So starting along the edge, kind of curve in, hit 0, curve up to run along the asymptote. And I can actually take from 0 and extend back, which is why I wanted you to plot that other little line there. So what you're looking at, it does kind of look just like this squiggle, right? And if I show you, if here's tangent of x, as long as I am in radian mode, which I am, if I do zoom trig, it's going to show you from negative 2 pi to positive 2 pi. Here is the graph that we're looking at. So it's kind of like these waves that repeat and then disappear. It's not as easy to model something like real life wise, if you will, that takes place with tangent. Because what do you know that increases, disappears, and then starts all over again? There's probably something, but off the top of my head, I'm not coming up with anything, okay? So what I want you to note from this is that the pattern repeats. So I'm going to say it repeats the pattern over a period of, take a look, one of these cycles right here. This one in particular goes from pi over 2 to 3 pi over 2. What's the difference from pi over 2 to 3 pi over 2? Well, it'd be 2 pi over 2 or just pi. So whereas sine and cosine have a period of 2 pi, tangent is different. Tangent has a period of pi, all right? So that's specific for tangent, right? I didn't mean to write tangent. They will go like that. As for that, then, what's the actual domain here? Well, the domain is all the values except for when it disappears, right, on the asymptotes. So you could write it using interval notation. We'd kind of have to go a little like ... and say like, all right, it goes from negative pi over 2 to positive pi over 2, union with positive pi over 2 to 3 pi over 2, and then keep playing the game. Union with 3 pi over 2 to 5 pi over 2, and then I'm just going to go ... because it keeps going. You can't, I'm not going to list them all out. That would be crazy because you can't. There's an infinite number of intervals. The range of values, though, think of sine and cosine. Sine and cosine are trapped between 1 and negative 1. I didn't even bother to label the y-axis because that arrow goes on forever up and forever down. So it's going to cover everything from negative infinity to positive infinity. It is not bounded at all. So that is the basics of your trig graph or your tangent graph. You really don't need to know anything beyond those specifics. The next thing up is handing in the homework. Next week, we've got the review and then the test. And last thing, I posted a little video for you guys on the main page of my website where you can meet the new puppy. So go check it out. All right, have a great rest of your day, guys.